Bonjour les élèves et bonjour tout le monde. C'est une nouvelle leçon du playlist AddMaths en créole, toujours sur le chapitre de Differentiation and Integration. Là, c'est la leçon numéro 11. Et là, comme dans la vidéo précédente, on réinclut le syllabus sur la première page. OK? Et sa partie syllabus là, nous finit covered in the first 9 lesson, dans la première 9 leçons, nous finissons cover sa partie là, avec sa partie sur differentiation là. Et understand integration at the reverse process of differentiation, nous cover ça dans leçon 10, dans la vidéo précédente. Et puis là, nous avons 3 parties sur integration là. Et aujourd'hui, je focus sur the integration of polynomial, c'est-à-dire sa partie là. Bon, maintenant, nous bien comprendre les affaires. Et nous déjà connaissons differentiation and integration concepts. Nous déjà connaissons what does integral sign mean, integration sign mean, ça affaire-là. Et nous déjà connaissons the difference between indefinite and definite integrals. Definite integral, c'est an integral within boundaries, known boundaries. Indefinite, ça veut dire nous avons boundaries, et là nous avons un arbitrary constant. Et nous aussi connaissons the geometrical viewpoint of single integration. OK. Et nous comprenons que when we integrate, we are actually finding the area under the graph, bounded by the graph and the x-axis within boundaries, bien sûr. OK. Bon, là, maintenant, mon champ est un peu trop gros. Voilà. Là, maintenant, if y is equal to x, equal to fx, pardon, then integration of y dx is equal to integration of fx dx. Simple définition, simple logique. If dy by dx is equal to g of x, therefore integration of g of x is equal to y plus c, where c is an arbitrary constant. OK. Et à chaque coup, nous besoin mettre ça C là, et à chaque coup, nous besoin dire que C, c'est un arbitrary constant. OK. Maintenant, integration of some common polynomial function. Premièrement, if the function is a constant, for example, integration of alpha. Nous connaissons que d by dx de alpha est égal à 0. Bon, bien sûr, nous pouvons revise the differentiation also. Et en même temps, nous pouvons faire the integration. Differentiation of a constant, c'est 0. And integration of a constant with respect to x, bien sûr, c'est alpha x plus c, where c is an arbitrary constant. Deuxièmement, the function is a times x to the power of n. d by dx de a x to the power of n is equal to a multiplied by sa power là, and multiplied by x to the power of 1, n minus 1. We decrease the power by 1. Okay. And integration of ax to the power of n dx is equal to, nous les séparer, et les séparer. Okay. X to the power of, we increase the power by 1. Nous augmente le power par 1. X to the power of n plus 1. Et comment ici, nous multiply by the previous power. Ici, we divide by the next power. The next power, c'est n plus 1. Et nous divide by n plus 1. OK? Integration of a times x to the power of n dx is equal to a times x to the power of n plus 1 divided by n plus 1 plus c, bien sûr, where c is an arbitrary constant. Arbitrary constant. nous bien écrire ça, hein. Et si c'est arbitrary constant. Et bien sûr, n cannot be equal to -1. If n is equal to -1, then ça affaire-là vient infinity, vient undefined, et là, il y a un problème. OK? N cannot be equal to -1. Ça veut dire integration of a over x, li pas vient de la forme là. OK? Parce que n is equal to -1. OK? Il y a une autre forme, et plus tard, nous pouvons faire. Bon, we know that integration is not only the reverse of differentiation, but the processes involved in integration are also reversed. For example, si ici, we are multiplying by the previous power. Ici, we are dividing by the next power. Okay? The processes involved in integration are also reversed. Troisièmement, d by dx de, en bracket, ax plus b to the power of n. Ça veut dire, we multiply by the differentiation of this part. Et, ça veut dire, differentiation of b c'est 0, differentiation of a times x c'est a. We multiply by the previous power, n, and then we decrease the power by 1. A n times ax plus b to the power of n minus 1. Bon. Integration of the same function, ax plus b to the power of n dx. Toujours bisa integrate with respect to a particular variable. The same, we differentiate with respect to a particular variable. Okay? Et là, we have to increase the power by 1. Increase power by 1. N being n plus 1. We divide by the new power. But we also divide by the differentiation of the inside. OK? Et là, je trouvais que ça et là et A is equal to d by dx de ax plus b. We are dividing by the derivative of the inside function and not by the integral. Attention, je crois que parce que we are integrating, we have to divide by the integral. We have to divide by ax squared divided by 2. No. And not by the integral. Et là, nous sommes capables de vérifier. Nous vérifier et d by dx de ça, nous supposons gagner ça. D by dx de ax plus b to the power of n plus 1 divided by a times n plus 1. Bon, a times n plus 1, c'est une constante, là. Et we decrease the power by 1. N plus 1 minus 1 becomes 1. N. We multiply by the previous power. The previous power was n plus 1. Okay. And we multiply by the derivative of the inside function, which is equal to a. Ça veut dire, ça et ça coupé, il devient ax plus b to the power of n. Okay, so we have verified. Okay, sa théorie qui nous peut dire que we divide by the derivative of the inside function and not by the integral, livré. Okay, we have verified it. Quatrièmement, bon, là, c'est sum or difference of functions of x. Okay, integral of f of x plus or minus g of x dx, c'est integral of f of x dx plus or minus integral of g of x dx. Bon, à ce là, nous sommes capables de faire un exercice sur the integration of polynomials. OK. Exemple 1, integration of 5 dx est 5x plus c. C, c'est arbitrary constant. OK. Integration of 3x to the power of 5 dx, it means 3x to the power of 5 plus 1, it means 6, and divided by 6 plus c, it means x to the power of 6 divided by 2, 3 over 6 means 2, 1 means 1 over 2 plutôt, et plus c, where c is an arbitrary constant. Integral of 2x cubed minus 3x plus 6 dx, we use this property. OK? Ça veut dire, nous pouvons intégrer ça, nous pouvons minus integration of ça, nous pouvons plus integration of ça, et bien sûr, nous pouvons plus c à la fin. 2x, we increase the power to the power of 4 divided by 4. Minus 3, x squared, we have increased the power divided by 2, plus 6 times x divided by 1 plus c. Et là, on a x squared, x to the power of 4 divided by 2, minus 3x squared divided by 2, plus 6x plus c, where c toujours is an arbitrary constant. Quatrièmement, nous avons une affaire comme ça, x times de 3x squared plus 7 over x dx. Et bon, là, c'est une integration of a product of two functions. Et la façon qu'il nous peut faire, nous, OK, et nous pouvons expand the function, OK, nous pouvons expand the function, nous faire, par exemple, nous faire 3x cubed plus 7, it is the product in vanish, OK, the product in vanishes, et là, il est facile pour nous integrate. Integral of 3x cubed plus 7 dx, leaving 3x, we increase the power by 1 to the power of 4 divided by 4 plus 7x plus c, where c is an arbitrary constant. Exemple 2. Find the equation of the curve which passes through the point de 10 to 10 and for which dy by dx is equal to 3x squared minus 4 over x squared. Bon, solution, bon, given this part, y is equal to integration of, on bracket, 3x squared minus 4 over x squared dx. It means 3x cubed divided by 3 minus 4, parce que 4 over x squared, c'est x to the power of minus 2. We increase the power of minus 2 by 1. Minus 4 times x to the power of minus 2 plus 1 divided by the new power minus 2 plus 1 plus c. It becomes x cubed plus minus 2 plus 1 means minus 1. Minus divided by minus is equal to plus 4 times x to the power of minus 1. Which becomes plus 4 divided by x plus c, where c is an arbitrary constant. Bon, we have to eliminate c parce que il donne nous that the curve passes through 2 and 10. On a juste pour remplacer là-dedans. Y is equal to 10 et x is equal to 2. Okay, 10 is equal to 2 to the cube plus 4 over 2 plus c. 10 is equal to 8 plus 2 plus c. c is equal to 0. Therefore, the equation of the curve is y is equal to x cubed plus 4 over x. C is 0. Bon, maintenant, definite integrals, OK? Nous déjà, from the previous lesson, nous déjà understand what is a definite integral, OK? Integration of between the boundary 0 and 2, x, no, with respect to t. T is equal to 0, t is equal to 2, en bracket, 4t squared minus t dt, et 4 times t to the power of 3 divided by 3 minus t times minus t to the power of 2 divided by 2 and between the boundary 0 and 2. Et là, nous remplacer 2 là-dedans. 4 fois 2 à la puissance de 3 divisé par 3, retirer 2 à la puissance de 2 divisé par 2, retirer 0, si nous remplaçons là-dedans, function of 0, divine 0. Nous pouvons évaluer plus que ça, il est déjà 0. OK? Ça veut dire 4 fois 8 divisé par 3, retirer 2, which is equal to 4 fois 8 divisé par 3, retirer 6 sur 3, divine 32, retirer 6, divine 26 sur 3, c'est 8 sur 8 de l'eau 3. 8 de l'eau 3. Exemple 4. Given that integration of 1 between 1 and 3, h of x dx is equal to 5. Evaluate integration between 1 and 3, between the boundary x is equal to 1 and x is equal to 3. Et en bracket, h of x plus x dx. Bon, là, nous servit sa property là. This property. OK? Là. Et integration between 1 and 3 h of x plus x dx, nous casse-li, given integration between 1 and 3 h of x dx plus integration between 1 and 3 x dx. Et ça line de nous, it is given. And it is equal to 5. Okay, so 5 plus this part, x to the power of 2. We increase the power of 1 by 1, leaving x squared divided by the new power divided by 2. Between, we have to evaluate it between x is equal to 1 and x is equal to 3, which is equal to 5 plus 3 to the square divided by 2 minus 1 to the square, divided by 2, 5 plus 9 over 2 minus half, 5 plus 8 over 2, 5 plus 4, which is equal to 9. OK? Et là, moi, arrête la leçon. Moi, stop the share parce que la leçon est finie là. OK? Ça veut dire stop the share. Et for the integration of polynomials, moi, pensez, nous finissons couvert the basics. Bien sûr, plus tard, peut-être nous allons faire quelques questions d'examen, mais the basics has already been covered. Et my next lesson on this, sa playlist là, OK, les poulots derivative of trigonometric, non, integrals of trigonometric functions. Moi, je vous dis au revoir et à la prochaine vidéo.